Hey Physics 100, I want to go over the calculations for the third circuit in the simulated lab that we're doing. This is for experiment 13. I already put up on Moodle and YouTube circuit number 4, which is even more difficult than this one. But let's go ahead and do circuit number 3 so that you feel comfortable going back and doing number 1 and 2, and more importantly that you're comfortable doing it on the exam. The thing that you want to do when you look at a circuit is you want to ask yourself, what kind of a circuit is it? So this is a combination circuit because it has a resistor that is in series with the battery, followed by two resistors that are in parallel with each other that get back together. So the first thing we need to do is simplify the circuit so that it's just a series circuit. And the way we do that is replace these two with another resistor that has an equivalent resistance. Okay, now it would be very easy to just guess that you add these up and get 100, or that it's just 50. It's not going to be either one. Okay, basically, when you add a second route, if this route was like this, then those other wires weren't there, then this would be a 50 with a 50. So when you add this second route, the new resistance has got to be lower than either of the other ones by itself. Like if I take out this pathway and now you have to go that way, then this is just 50 plus 50 would equal 100. Now that I have two choices, the overall resistance is, in this case, is actually going to be half of that number is going to be 25. But I want to show you how you get that number. You get that number by using the formula for resistors in parallel. And here it is, 1 over RT is equal to 1 over the resistance of the first resistor in parallel plus 1 over R for the second one. So 1 over 50 plus 1 over 50. So 1 over 50 comes out to 0.02. This one comes out to 0.02 obviously as well. Then you add them up, you get 0.04. Okay? That's 1 over RT. We want RT. So how am I going to get that? I need to just, in my calculator, take 1 divided by 0.04. I need to get the reciprocal of this number so that it gives me the reciprocal of that. So I'm flipping this over and flipping that over. Right? Does that make sense? So if I take 1 over RT, I get RT. And if I take 1 over 0.04, I get 25. Okay, well that makes sense. Whenever you have two resistors in parallel with the same resistance, the equivalent resistance will be half that much. So now we've replaced this with a 25 ohm resistor. Well, if I take my 25 ohm resistor and I put it right where the 50 used to be, the 250s used to be, I see now I have a very easy circuit. I have a circuit with an overall resistance that has two resistors in series with each other. So all I have to do when they're in series is add them up. So 50 plus 25 is going to give me 75. So that's the overall resistance. So that's one of the questions that they're going to ask, the overall resistance of the circuit is 75. I add those two up, right? 75 ohms. Okay. Second, what's the current through the bigger part of the circuit? Or you could just think about it, what's the current through the battery? Because the battery is in a pathway with anything, right? There's only one way through the battery. So even if I take this off, there's still only one way through the battery. So however this breaks up and gets back together, you're going to have the total current all the way through this whole part of the circuit that's together. Then it's going to break in half. Half is going to go this way, half is going to go that way, and it's going to get back together over here. So that's pretty easy. How come that calculation is so easy? Because they have identical resistances. The current, the likelihood of an electron going this way is just as high as this way. They're both equally difficult. They're both difficult by 50 ohms. One isn't harder than the other. If one was 100 and the other was 50, 2/3 of it would go through this way and only 1/3 would go through that way. But since they're equivalent, it's going to split equally. First we have to figure out what that overall number is. So what is the current through the battery, or the overall resistance? All right, so I know the voltage through the battery is 100 volts, and I know the overall resistance of the circuit is 75. So V is equal to IR. So I is equal to V over R. So you use it that way a lot. So I is equal to V over R. So the voltage is given to you. It's written right on the battery. That's where you're going to get that. The total voltage is going to come from whatever's right on the battery. 100 volts divided by 75 ohms. This answer comes out in amps, right? That's the unit for electric current. You know what this is going to be, but let's make sure. It's 100 divided by 75 is equal to 1.33. Okay. Amps. Okay, now we can start to do a lot of the next steps logically. If 1.33 is coming out of the battery, then 1.33 makes this turn. There's only one pathway, so 1.33 has got to go all the way through this 50. So what's the current going through here? The current is 1.33 amps. Comes down. It's got to split equally. Why? Because there's only two pathways and they're of equal difficulty. So the current in resistors that are in parallel splits, and it splits equally this time because they have the same numbers. If they didn't, we'd have to do a little bit more math. This is an easy one. They split equally. 1.33 divided by 2. I get 0.667. So I'm going to just round that to 0.67. So how much current is going through this arm or this side? Half of that, which is 0.665. So I'm going to say 0.67 amps. And same goes this way. Okay, then the 0.67 and the 0.67 come around this turn. Come around this turn, meet up. Guess what? Of course they're going to get back together, add them back up. You're going to get 1.33. Okay, 0.67 plus 0.67 is 1.33. 1.33 zips all the way back through here. Okay, so now we know the current through the battery is 1.33. The current through R1, this is R1, right? This is R2, this is R3. Okay. Current through R1 is 1.33, splits in half, so the current through R2 is half that amount, and the current through R3 is that same number. Right? Get back together, add up, rest of the way goes that way. Okay, so the last thing we need to do is just figure out what the voltage drops are. So the way this works is that the voltage gain at the battery supplies the potential energy. The voltage gain is 100, so you're at like a height of 100 above zero up here, right? And then you're going to drop some over here, and then you're going to drop the rest here. One thing we can tell, I don't know what this number is going to be yet, but I'm going to tell you, going this way and going this way, if I go on two hikes, and one way I go that way, and one way I got to meet back at the same place. So not only is the current the same in this case, but the voltage drop is going to be the same. The voltage drop is always the same, no matter what the resistances are. The voltage drop is always the same across two resistors that are in parallel. Okay? Here, the current always splits in half. It happens to be exactly the same because these numbers are the same. But I don't care if this is 1,000,000 amps and this is 50 amps. The voltage drop this way and this way has to be the same, because if no matter what pathway I go, when I leave that point, the difference between there and there is independent of which route I take, right? If I go this way or if I go that way, I've got to end up in the same place. Okay? So let's figure out what that is. The way to get the voltage drop is pretty easy. That's the current through and the voltage across. Voltage across anything is equal to V is equal to IR. So if I know the current and the resistance at any individual component, I can get the voltage. So V is equal to I times R. So if I multiply these two things, I'll get the V1 over there. okay? So my expectation, well, I don't know what my expectation, I'm not gonna have an expectation. Let's do 50 times 1.33. 50 times 1.3333. Okay, 66.5 amps, 66.6 amps gets dropped over here. All right, I had 100, I lost 66. After I go through either this way or this way, remember they have to be the same, I gotta get to 0 because there's no more components in between, and I know the total voltage drop is 100. So if this guy's 66, the voltage drop across this way or this way has to be 100 minus 66. Now I'm going to do the math for you to prove to you that it's always V is equal to IR. I know the current and I know the voltage, but I also could have figured it out because I know the first one. I know what this one is. And the total all the way around has got to be equal to 100. Any pathway I take, I've got to lose 100. Why? Because I get back to the same spot. I get to the starting line. Then I click up to 100. Woof! Roller coaster down, right? Get 100. Drop 60. I got 33 left. Drop 33. I'm at 0. Get 100. That pathway or that pathway, both of them have to be the same. Okay? So V across 1, voltage across resistor 1 was 66.6 volts. Let's do it. I'll show you that I still get the 33 like I'm expecting. I know the resistance and the current over here at R2. Okay? So if I take 0.67 times 50, I get 33.5. Right? It really should be 33.6. No, it's actually 33.4. Right? So this is, because I wanted to add up to 100. So 66.666, 66.6, and 34.4 will add up to 100. And then V3, it's got to be exactly the same because the numbers are the same. Look, 50 ohms times 0.67. The voltage times the current at any component, V is equal to IR, right? The voltage times the current, any place along the circuit has got to be equal to, the current times the resistance has got to be equal to the voltage. Okay, so that's the last three. So it's 66, then it goes to 33, 33. Does that make sense? And I don't know what else I would have asked you. I think that's pretty much it. So how much is this guy? This is V2. How much this drop is? 33.4 volts. And this one, V3, 33.4 volts. Any pathway I drop, I've got to drop the 100 I just put in. Okay, one more time. The battery clicks you up to plus 100. You come around, drop 66 out of the 100, go this way, drop the other 33, you're at 0. Because when you leave here, the rest is just wires. Look, wires don't have any resistance or minimum resistance. It's only when I go through the component that I have a voltage drop. Okay, go the left way this time. Everybody's got to go through here, 0.66. Down through here, I drop another 33, 66 and 33 is 100. Right here, when I get to this wire, I'm at 0. If I would touch my voltmeter right there and right here, I would see 100 volt difference, right? Okay, that's everything that I have for doing circuit number 3 for the lab. Okay. Thank you. See ya.